Hello everyone. So in this video I will be sharing a problem related to priority queue which I have faced in interviews at Amazon and Adobe, and I have seen other companies also ask, but personally this has been asked me while interviewing at Amazon and Adobe. So let's quickly go through the problem statement. So the problem statement is you have some sticks with positive integer lengths. You can connect any two sticks of length x and y into one stick by paying a cost of x plus y. You perform this action until there is one stick remaining. Return the minimum cost of connecting all the given sticks into one stick in this way. So to understand the problem statement, it is given that you are given an array of integers, and what you can do is you can connect any two integers into one. Basically it is an array of length of sticks, and you can pick any two sticks of length x and y, and you can combine them into one stick, but there is a cost of that operation which is equal to the length sum of their lengths, right? And you have to perform this action until you are left with just one stick, right? And then since each operation has a cost, whenever you are picking up two sticks and you're combining them, there will be a cost, and again you will be picking up another two sticks and you will be combining them. So there will be a total cost associated with this complete operation, and you need to minimize that cost. So in some interviews you would see that interviewer is replacing sticks with ropes, and in some interviews interviewer will be saying tapes instead of sticks. So terms might change, but basic skeleton of this problem will remain same. Let me copy this problem here so that we can solve it on the same screen. And by the way, if you search this problem on LeetCode, you won't be able to find it if you don't have a premium, because it is a premium problem. So coming back here, let's copy this sample input also. So what you need to do is combine the elements into one and optimize the total cost is what you need to do. So if you have this array, so let's say if you combine these two elements first, 2 and 4, because this is what you need to do. You basically need to keep combining the elements of the array until you're left with just one. So if you combine these two elements, you would this would give you a new element of length 6, basically a stick of length 6, and this is your cost for this operation, right? And now you are left with 6 and 3 from here, right? So these are the two sticks which you're left with. So this is what you combine 6 and 3, so it will give you a new stick of length 9, and the cost of this operation was 9. So what is your total cost? Total cost is basically sum of all the cost, so it will be 6 plus 9, right, which is 15. So one part where I have seen that the candidate confused whenever I have also asked this problem is that they get confused, like how is the cost going to be different in different scenarios. So let's quickly see if we combine in other sequence, what will be the cost if we would have combined 2 and 3 first, because in the problem statement there is no such constraint that you have to keep combining from left to right or which order you need to combine. So you can pick any two elements from the array and you can combine them. So if you pick 2 and 3, so the cost will be 5, and now you are left with 4 and 5. So when you combine 4 and 5, you will be left with 9, right? So what is the total in this scenario? Total will be 5 plus 9. This is equal to 14, right? So this is how, based upon what you are combining first, the cost can be more or less, right? So let's basically try to see how these totals are coming out to be different. If you want to express this in terms of this cost in terms of the actual elements of the array, so you would see this is basically 6 plus so let's first break down this. from where is this 9 coming? This 9 is coming from 6 plus 3, right? Where you combine this, and this is the 6 which you used here basically. And how is 6 coming? 6 is coming from 2 plus 4, right? So this is how you will replace it. So this is how you would be representing your total cost in terms of the initial elements that you have, right? And let's do the same thing for this part also. So how is this 9 coming? This 9 is coming from basically 5 plus 4, right? And how is this 5 coming? This 5 is coming from 2 plus 3, right? So this is how you would represent. So you will say the sum is 14 for this case and sum is 15 for this, right? So what you would see is that when you combine 2 and 4 for the first time and you added it back to the array, so that element gets added to some other element and it gets added multiple times in the total cost, right? So whatever you are combining early in the beginning, it is definitely going to be added again if there are sufficient number of elements, and you would see that cost getting added again and again. So the difference between these two is that the starting elements which you combined here, so they resulted into a lower number. So 2 plus 4 is 6 and it again got repeated here, so 6 got repeated, and here it is 2 plus 3 5, it got repeated, so 5 got repeated. So this is how the cost difference is coming, and by now you would have basically resolved this thing that to optimize the cost you should first be combining the smallest elements, right? So this is a greedy solution. That's how this problem would be solved. What you need to do is, from your array, whatever array you are given, let's say this is the array which you have been given, there is a 3 also, right? So what you need to do from your arrays, you need to pick the 2 smallest elements and you combine them, so that whatever is the resulting element you have, whichever is going to be repeated, it is also the smallest, so that the total contribution of it to the total cost is the least. So let's say from this array you pick 2 smallest elements, 2 and 2, so it will result in 4 cost so far, and the remaining elements are here, right? And now you have this new stick which you would be adding to your existing array. So now again you need to pick or basically find the 2 smallest elements from the array, and basically 2 and 2 are the smallest one. You shouldn't be getting confused here that okay, every time I would be picking the first 2 elements, first I sort the array and then I would pick the element. So with this approach, if you do this thing, what you need to do is, so if you look at the total number of operations with 3 elements, there are 2 operations. First you combine, let's say 2 and 4, now you combine the remaining element with 3. If you see, there were total 2 operations. So let's say if we have n sticks, how many total operations will be there? There will be n minus 1 operations, right? Because in one step you are combining 2 sticks and eventually you would be just left with the 1 stick, and there you would stop, right? So what you need to do is, in each operation you need to fetch the 2 smallest elements from the array. So one approach is that in each operation what you are doing is you are sorting your array, whatever array you are given in the beginning, you just sort the array, you fetch the first 2 elements of the array, you define that okay, new element is equal to 0th element plus the second element, and then you insert this number back to your array, and you basically remove these first 2 elements from the array, right? And what you can do is, if you initially sort your array and you are doing this operation, so you can insert here in a sorted way, like so that your array keeps sorted, sorted all the time. But talking about the time complexity with this approach, what is the time complexity? So first you sort the array, that is n log n, right? and then you are doing a loop of n minus 1 because there are n operations. So inside each loop what you are doing, you are picking first two elements of the array, and then you are calculating their sum, and then you are inserting this new element in your sorted array, which is a big of an operation because you need to shift the elements in the array if you want to insert in sorted one. So your time complexity becomes big of n square, right? And basically how you are calculating the total cost is like you would initialize total by 0, and in each iteration you would do total plus is equal to num, right? And what is your space complexity is big of 1 because you are using just 3-4 constants, not more than that. So why did I mention this time and space complexities? Whenever you are in a DSL Go interview, you should be telling the interviewer what is the space and the time complexity, because only then you would be able to compare different approaches in the front of interviewer. And this is also data point which interviewer notes whether you know how to calculate the right time and space complexity, and whether you know how to optimize the solutions by looking at what time or space it is taking and what are the areas for optimization. So if you look at what optimization can be done here, so what we are doing inside each iteration is we are just picking the two smallest elements from the array and we are combining them. So if we want to just find the two smallest elements in the array, we don't need to sort the whole array. We just need to the smallest element and then the another smallest element. So here we can use a data structure like mean heap or priority queue, where your top element is the mean element, and basically you fetch the element in a log n complexity, or basically average is big on 1. You can look about the details of it, but it is optimized as compared to keeping an sorted array, because rebalancing a mean heap is much less costly as compared to inserting an integer in a sorted array. So how you would do it with priority queue is you are given an array, you convert it to priority queue or basically mean heap, right? And now what you do is you initialize your total cost as 0, and now you run n-1 iterations. So the way you can write the loop condition is basically your priority queue should have at least 2 elements, right? If it has 1 or less than 1 element, then basically you're not combining any sticks and there won't be any cost. So you pull the first element from your priority queue, right? And basically you fetch the second element from your priority queue. Then you say your new num is equal to n1 plus n2, and to your total you add this number. To your priority queue also you add this number, which is a new stick, and towards end you return the total is what you return. So what happened here, let's see. You build a priority queue from your array, and now in this priority queue you always have the mean element on the top. So in your iteration what you do is you pull the top element from priority queue, and now you again pull the smallest element from the priority queue. So what happened here is when you pull the minimum element, so from the remaining elements whatever was the minimum element, it comes on the top because priority queue rebalances. So this poll operation is basically a log of n operation, where n is the number of elements in the priority queue. And now you have the two smallest elements. You calculate what is the new stick, and their sum is also the cost for this operation. So you add this number to your total cost, and this new stick which was formed from combining those two, you add it back to the priority queue, right? And you keep running this loop until you are left with just one element in the priority queue. So let's quickly code this. Let's initialize our array. We will take this example only for now, right? Now what you do is you define a priority queue, right? And now you iterate through each element of array and you add it to your priority queue and initialize that your total cost is equal to 0, and you say while priority queue dot size is greater than 1, you say your num1 is equal to priority queue dot poll and your num2 is equal to priority queue dot poll, right? And you say your new num is equal to basically n plus 1 and 2, and to your total you add your cost, and to your priority queue also you add this num, right? And towards end you return the total. So let's also look at the time complexity for this. So when you're converting your array into priority queue, it is n log n operation, and you're also using big O of n space since you're creating a new priority queue which would have its own space. And this while loop, this is big O of n, right? And this is log n operation. Again, this poll is log of n operation, and inserting is also log of n operation. So this part basically becomes your n log n, and this part was also n log n. So your time complexity becomes big O of n log n, and your space is big O of n. Now if interviewer asks that you need to optimize this space, so there are two different ways interviewer can check this. So either he could say that reduce this space, or they could say that don't use this priority queue from the library. So what interviewer is trying to check here is whether you can implement your own main heap or not. So we can see that part also, but I would not keep it in the scope of this video. You can search on net, or I will create a separate video on how to heapify this array, how to build a main heap out of this array itself. So if you compare two solutions, this has time complexity n log n, earlier solution has n square. So in terms of time, this solution is definitely optimized. So let's run this code and see what is the output for this. It says return, okay. Instead of returning, let's print it. Total cost, what is going to be. Let's run it. So total cost is 14. Okay, 14 is the right answer for this. Let's run for this one also. So 30 is the right answer for this. So what you can do is when you are in the interview, you can show interviewer that you are checking for a couple of edge cases, like there are no sticks, or if there is just one stick, what is the output in this case, right? Or you can use such a case. So this is how you can solve this problem. I will also create a separate video for the heapify of the array, and will share other interview experiences also with you. Till then, keep practicing. All the best for your interviews. Thank you.